This is the first step of the final project where we build a complete intercom system. And for this step, well, we are not going to write any code. We are going to define the protocol we will use to communicate between the Arduino and the Raspberry Pi, and also between the Raspberry Pi and the Telegram application, okay? Because when you communicate between both sides, you need to agree on what you send and what you receive so you can correctly process the comments and the messages. So I'm just gonna open, well, I'm gonna open Genie here just to write some text. So what you can do, what I would recommend is just write the protocol on paper first, okay, just a pen and paper, that's it. Or just open any text editor you want on the Raspberry Pi or on your phone, on Windows, or well, basically anywhere you want, okay, it doesn't really matter. It's just to write the protocol that then you keep on the side for the duration of the project. So first of all, we're gonna focus on serial communication. I'm gonna put it full size, okay. And then on Telegram communication. So what do we need for serial? So basically between the Arduino and the Raspberry Pi. First, let's do the commands that are going to go from Arduino to Raspberry Pi. I'm gonna write RPI like this. What do we have? Well, we have just one output we want to send is when we press on the push button. And when we press on the push button, we can send the command, for example, button pressed with \n. Okay, I'm gonna add \n here so that the command is complete. So we send this, so we've already done that actually in some of the previous activities. We send this from the Arduino, we receive that on the Raspberry Pi. Then that's it for this side of the communication. We have then the RPI to the Arduino. Here we have a few more commands. So we are going to control the RGB LED, the buzzer, the servo motor, and the LCD screen from the Raspberry Pi. And so what commands exactly are we going to send? Let's first think about the servo motor. So basically the command we want to do is not to move the servo motor at a high level, is more to open the door or to close the door. Because this is an intercom project, while the servo motor is linked to the door. So what I'm going to do is I'm going to send a command open door \n and close door \n. And the Arduino will be responsible for moving the servo to the correct position when it receives open door and moving the servo to the close position when it receives the close door command. Okay, I could send directly the angle of the servo to the Arduino, but well, actually, this way may be better. Okay, we send open door, close door, and the Arduino knows, because the Arduino is closer to hardware, the Arduino knows what is the angle to send the servo to, what is the speed to move the servo, etc. Okay, so we are done with the servo and with the open and close door functionalities. Then when we open and we close the door, we also want to set the RGB LED, the buzzer, and the LCD. So let's start with LCD. We are going to send print text colon, and then let's say this is some text \n. So we have already done that before. We send the print text command with colon, and then we're gonna extract this from the command. Okay, so this is an exact command. We are gonna check if it's equal to open door. Here we're gonna check if the command starts with print text, and then extract this and print this on the LCD screen. Now for the buzzer. Well, we haven't used the buzzer in any activity before, so that's something new. What can we do to send command to the buzzer? So we want to play a sound on the buzzer, and to play a sound, we need to give two things, the frequency and the duration. And so I'm gonna put a command, let's say play buzzer colon, and then frequency, comma, duration \n. So on the Arduino, we're gonna first check that we have a command that starts with play buzzer colon, and then we're gonna extract so this, and we're gonna find the index of the comma, and then everything before the index is the frequency, everything after the index is the duration. Okay, so the frequency can be anything from, let's say, 20 Hz to 20,000 Hz, And the duration also can be anything from 1 millisecond to whatever milliseconds you want. And then we have set LED because we want to set the RGB LED with red, green, and blue \n. And so here we're gonna follow the protocol we have used previously in one of the other activity, which is to say that each color will be exactly 3 characters. Okay, so as an example, we have set LED. Let's say you want to give 3 for the red, and then 255 for the green, and then 0.50 for the blue. Okay, you're gonna make sure that each color gets 3 characters. Okay, let's just actually do an example for the play buzzer. Play buzzer, let's say for example 200 and 1000. So 200 frequency, 1000 milliseconds. And so we're gonna handle actually those 2 commands a bit differently in the code, in the Arduino code. So we have covered all the functionalities here and all the components between the Arduino and the Raspberry Pi. So we're gonna keep this on the side. And so when we work on the Arduino, we know what to send and what to receive. And when we work on the Raspberry Pi, we know what to receive and what to send. Okay, we don't need to always compare the 2 codes. We can just refer to this document. And then we also need to define what command we are gonna send and receive from Telegram. So, well, when we actually send the notification with a message and a photo, there is no specific command to agree on because we're just gonna send a message on a chat using the chat ID. But when we receive command, we need to check what command we receive so we can process them with a handler in the Python code. And so we're gonna have the start command as always. And then to open the door, we're gonna use open, like you could see in the demo, and to close the door, actually to deny access, not to close the door, but to deny access, just deny. So with start, we can get a welcome message. When we receive a notification, we can send open to open the door, or we can send deny to deny the access. And well, that's pretty much it. So I'm going to save Control S this as protocol.txt. Okay, and keep it on the side for the duration of the project. And now that we have this, we are ready to start writing some code with the next step.